Hey, Year 1005 mathematicians, Mr. Hermit here, and this topic will be looking at lesson 4, exercise 4D, bearings, and specifically we're going to be looking at true bearings for this topic. This video will be split up into 3 parts, and this will be part 1 out of 3. It's highly recommended that you watch this part first before you watch part 2 or part 3. Part 1, we'll be looking at the theory behind true bearings and a few simple examples. Part 2, we'll be looking at a few more examples and some tricky examples in regards to true bearings. And then part 3, we'll be looking at some real life examples and how true bearings can be used in real life context questions. The learning goal for this topic is to be able to understand how true bearings are measured and written, and the success criteria for this topic is to be able to state a true bearing and its opposite direction from a diagram, and to also be able to apply bearings in word problems using a diagram and trigonometry, which is from the previous topics. For now, let's have a look at what true bearings are. Now, it kind of takes a bit of a jump, true bearings, from one topic to the previous topic, which was trigonometry and looking at sine, cos and tan. Sine, cos, tan does work in conjunction with true bearings, but there's quite a bit of context behind true bearings first that we have to wrap our head around. So true bearings are measured clockwise. So clockwise, you got to remember that when we talk about clockwise, clockwise goes in the same direction as a clock. Okay, so this is clockwise. And when we measure true bearings, we measure it clockwise from due north. So right here we've got this compass, and we should know hopefully by now north, south, east, west within this compass, which is our main compass points. Now instead of using up, down, left, right, we're so used to using north, south, east, west to do with the North Pole, and how we can use a tool of some sort like a compass for directions. So to keep it consistent, we use north, south, east, west. And when we measure true bearings, we always start at due north. This is always our starting point. Okay, and then we measure clockwise from due north, and that's what that sentence means. So from north to northeast, that measurement here is 45, and then we keep going again and we hit to east, which is 90, and this just keeps going around by little increments of 45 degrees for each quarter, or 90 degrees not quarter, sorry, for each eighth, sorry, and then 90 degrees for each quarter, and it should make a full 360 degrees. So technically north here can be considered as 2 different true bearing measurements, 000 degree and 360 degree. They both can suffice, just depending on how many rotations you have made. If you've made no rotations, you're at 0. If you've made 1 rotation, you're at 360. So some angles and directions are shown in the diagram, which I just talked about before. Just making sure that NE just stands for north, east, south, east, etc. True bearings are a very important point. True bearings are usually written using 3 digits. And we use this 3-digit system so we specifically know that we are talking about true bearings. Because sometimes you can get an angle of some sort that looks like this, and this angle could be 35 degrees. Because of the fact that there's no 0 in front of it, we know that we're talking about just some type of degree within an angle, or within a triangle of some sort, or within some type of different context. But as soon as you chuck that 0 in front of it, we know that we're talking about bearings. And now this is just specifically about degrees between 0 to 100 inclusively. But it's just to keep it consistent, we make sure that that 0 stays in front when we're talking about true bearings. And then obviously we have the degree sign as well. And this fact right here, I'm going to underline, because this fact really can confuse students when they attempt the questions. And this one says opposite directions differ by 180 degrees. And this keyword directions, putting a square around it, this is not obvious what it's talking about. Okay, it's not obvious. And I say not obvious in regards to the type of questions that you'll get. Okay. Just for now, keep this at the back of your head. Opposite directions differ by 180 degrees. we'll reference this when it comes to part 2 of the series of bearings. For now, we're just going to look at these 3 simple examples, and we'll look into more examples in the next video. But for now, for each diagram, we're going to give the true bearing from O to A. From O to A. Now, O here, this O just means origin. Okay, and it didn't specify in the diagram above, but when we're talking about a true bearing, we're always coming from due north, but we always have to have some origin, some starting point, which is always going to be in the middle of the compass, no matter what type of question you get. And so this says we're going to give the true bearing from O to A. So this is saying, okay, I'm going to A. Okay, so A is this point here, and I'm going to A from O. So I'm coming from my origin point. So from here, I'm going to walk along here, and I'm going to appear at A. Now A is just the point. Okay. We don't necessarily care about this length here. It's not asking for a length. It's asking for a true bearing. So it's asking for the angle from due north that is made between the line north and the line that has been made with OA. Because technically this A, this point can run anywhere along this line. It can be here, here, here. It can go further out. The length might change, but the true bearing will always be consistent. Okay, so just keep that in mind. So for each diagram, give the true bearing from O to A. In this case, the true bearing from O to A is going to be whatever that degree is. In this case, it's 50 degrees, but you gotta be careful about what type of the amount of numbers that you use in your answer. In this case, the true bearing is 0, 5, 0, and then the degrees. Remember, we just put that 0 there because we're dealing with true bearing. Now this one's a really simple solution because it's given the actual measurement here. But then when it comes to this type of question here for B, where it's asking for the true bearing from from O to A. In this case, we haven't been given what this degree is here, and that's what we're trying to figure out. But what we do know is that this 30 degree here has been provided, and we know that within a quarter there is 90 degrees. So the true bearing in this case, true bearing from O to A, this is going to be equal to the difference of 90 degrees and 30 degrees, because that's going to give us that missing part in here. So in this case, this will be equal to 0, 6, 0 with the degree symbol. So there is 60 degrees. So our answer is 0, 6, 0. And lastly, before we get to part 2, we're going to be looking at this point A being here, knowing that this degree is 49. So what we're looking for, starting at due north, going all the way down until we hit that line. Now some students say, oh yeah, that's easy, it's 49 degrees. Well, not necessarily. 49 degrees does have some form of importance within the answer, but you also have to include this chunk here, which is also 90. So our true bearing, in this case, our true bearing is going to be 90 degrees plus that 49 degrees, the additional 49 degrees to get from due north to the line OA. So in this case, 90 degrees plus 49 degrees is equal to 139 with a little decreasable. So that's what true bearings is all about. Now it does get trickier when we're talking about where we're coming from to. In easy questions, we're always starting from our origin and we're going to a designated letter. So A, B, C, D, depends on how many there are on the compass. But then you'll get questions that look at the true bearing from a certain letter to the origin. And that's where it gets confusing terminology wise. And there is a little bit of a thing that can help you out with this. But for now, we'll wrap this up and I'll see you in the next video.